All right, here's your last problem for your lesson before you can hop into homework. So, what we are looking at is real life examples. So, we've got a baseball diamond. It says a softball field or a softball field. A softball field forms a sector with the dimensions shown. Find the length of the outfield fence and the area of the field. So, the first thing we need to do, we have the dimensions. So we need to find the length of the outfield fence, and that right there is arc length. That's your arc length. And then the area of the field, obviously, and that's the area. So two different things. We've got the formula for our arc length, and that's determined by S, which is very interesting, but it's a sector, so that's why it's S. And it's R times theta. And the main thing we need to do is we've got our radius in 200s. We're going to go ahead and we need to change it into radians to work with it. So if you notice, it says the theta angle measured in radians in the prior problem. So make sure we change this to radians. So 90 degrees, that's 90 times pi over 180. That gives us 90 pi over 180, which is just pi over 2. So our radius is 200, and we've got pi over 2. And man, that's just 100 pi, and that's our length. And we should probably plug it in so we get a more accurate, and that's around 314 feet. So that's the length of that outfield fence. And now we need to find our area. Our area is found by 1/2 r squared times theta, which is our angle measure in radians once again. So 1/2 times 200 squared times pi over 2. 200 squared times 1/2, and then pi over 2, that gives us 10,000 pi. When you plug it in, you get around 31,416, and that would be feet squared because we are looking at area, and you could do the approximation. So hopefully you don't see that's too bad. You just got to make sure to put it into radians first and then solve each of the pieces.